Hey there, second grade. How's everybody doing today? And welcome back to another remote learning math lesson with Mr. Enzi. Now, some of you may have already received your grade 2 Mathmat resource pack. It contains a bunch of little math templates inside. If you have already received it, you're going to want to look inside and pull out the number grid, because you can take that number grid and place it in the sheet protector that you were given, because now you're able to take a dry erase marker and write on your number grid, erase it with a tissue or an old sock, write on it again. So this is a math tool that you may find helpful to use during today's lesson. So let's get started as I shrink myself into the corner. Today we are going to be doing grade 2, lesson 1.5. It's an open response lesson called Number Grid Puzzles. And if you have that Mathmat number grid and the sheet protector, that will help you. But I will also put a number grid in your seesaw activity, just in case you don't have the Mathmat pack at home yet. So let's get started. Our word of the day is the word pattern. So we've talked about patterns before in math, but a pattern is something that repeats based on a rule. So here is an example of a shape pattern. We see that things start to repeat. Red triangle, yellow rectangle. Red triangle, yellow rectangle. Red triangle, yellow rectangle. So it repeats based on a rule, and that makes it a pattern. What do you think would come next? What shape would come next? Well, hopefully you said the red triangle, because that would keep the rule going on and on. But here's another example of a pattern. Our numbers can become patterns also. Let's take a look at these numbers. 5, 10, 15, 20. What number do you think comes next in this pattern? 5, 10, 15, 20. Hopefully you said 25. This pattern is skip counting by fives. The colors also resemble a pattern. They all start with a dark red, yellow, green, and blue. So patterns can also involve colors. And here's another pattern. This pattern involves coins. These coins show a pattern. We have a penny, we have a nickel, and we have a dime. And we have a penny, and we have a nickel, and we have a dime. Which coin do you think will come next in this pattern? Penny, nickel, dime, penny, nickel, dime. Well, if you guessed the penny, you are correct, because this pattern is penny, nickel, dime. Penny, nickel, dime. Penny, and then I would need the nickel and the dime, because it's following a rule. Awesome job! Today we're going to take a look at our number grid and number grid patterns, things that make up some rules in our number grids. So we've seen and worked with number grids before. When we go across a number grid, something happens. We're counting by ones. Let's take a look. Here I have some numbers that are hidden, and it starts with the number 31. What comes next in our number grid? 31. Did you say 32? Now, if I wasn't sure and I had my number grid, I could always find 31 on my number grid and see what numbers come after it. What comes next? 31, 32. Did you say 33? Awesome job. And the last one that is hidden, what number would be there? 31, 32, 33. Did you say 34? Awesome job. When we go across a number grid, we count by ones. But we can also go up and down a number grid. I went and hid some numbers that go up and down the number grid. I start with the number 10. What number is underneath the number 10? So if I had a number grid, I would look for my number 10 and then go down. What number comes underneath the 10? Did you say 20? When we go down a number grid, we count by tens. 10, 20, 30, 40. So another pattern that exists is that when we go up and down, we are counting by tens. Let's see another example. Here, I covered some numbers. We have the number 6. And if I want to add 10 to the number 6, I get 16. If I want to add 10 to 16, I get 26. If I want to add 10 more, 36. If I want to add 10 more, 46. Notice another pattern exists. All the digits in the one place are always a number 6. So we have a 6, another 6, and a 6, and another 6, and a 6, and a 6. That whole column ends with 6s. But the beginning number, the tens place, always starts with a different number. And it's like counting in order. 1, 2, 3, 4, 5. Lots of patterns in our number grids. This column here ends with all 5s. This column here ends with all 3s. And then the number in the tens place, the first number, it's like counting. 1, 2, 3, 4, 5, 6. You're going to get a chance to take a look more closely at some number grid patterns. Today in your seesaw activity, you're going to be doing a math open response. An open response means that there's lots of ways to solve and answer a math problem. Whenever we do an open response, we score it a special way. We use 4 different numbers. Let me tell you what those numbers mean. You can score a 0 on an open response, but that would mean you did not try to solve the problem. Most mathematicians, like you, try to solve the problem, so you don't even have to worry about a 0. Our next score is a 1. And a 1 means that you tried to solve the problem, but your answer wasn't correct. Good try, but the math wasn't right. That's a score of a 1. But you can also score a 2. A 2 means that most of your answer is correct, but maybe your explanation is hard to follow. I like to say that maybe your explanation is fuzzy. And then you can score a 3. If your answer is correct and your explanation is awesome, you tell exactly what you did to solve the problem, and you use a lot of math words. That is a very impressive open response. But I have to tell you, 3s are hard to get. Most of our students score a 2 because we're still working at becoming better mathematicians. Today, in your seesaw activity, you're going to see that you have an open response where you're going to have to solve the problem and then explain how you got the answers. All right, my mathematicians, go ahead and get started. I can't wait to see your answers. See you soon.